Good morning. Myself, Karthikeyan, Assistant Professor, Department of Computer Science and Business System, KS Rangasamy College of Technology. So, welcome to this lecture on connection description the static model from software design with UML. So, it is a core concept in software design using UML. Today, we will explore how different elements of a system are connected, why these connections are important, and how they help us design robust and maintainable systems. By end of this lecture, you will understand not only the theory but also practical applications of these connections in real-world software designs. The next one is what is static model. Let's begin by understanding what is a static model. A static model is essentially a snapshot of the system at a specific point in time. It focuses on the structure and the architecture rather than behavior. Think of it like a blueprint of a building. So you can see where walls, doors, and windows are, but it does not show people moving inside. So in software, static models are so used to visualize how classes and objects are organized, component hierarchies in large systems. The next one is database entities and their relationships. So common tools for static models include UML class diagrams, component diagrams, and entity relationship diagrams. Static models helps developers understand the system's architecture before writing code and reducing the errors and design flaws. So this is known as static model. The next one is connections are the backbone of the connections model static models. So in this connections are backbone of the static models. Why? Because without connections, the system is the system is just isolated elements. So the in this connections defines how elements relate and interact, dependency and hierarchy, how the connections will be in dependency and hierarchies, and coherence and clarity in design. So imagine designing a car where each part exists but none are connected properly. The wheels, engine, and body would be meaningless if they don't interact correctly. So similarly, in software, unclear connections lead to bugs and also code and maintenance nightmares. So clear connections make system modular, easier to test and scalable. So this is known as connections. So there are three types of connections which is available in this. So first one is different relationships and dependencies and coherence. So the next one is the main types of relationships in static models. So there are three main relationships that you need to know. The first one is association. So this is a general link indicating awareness or interaction. So this is known as association. So for example, a customer uses a shopping cart. There is no ownership, but they interact. Think of it as two colleges communicating in a team. So the next one is composition. So here in composition, one element owns or contains another. So example, a car contains wheels. If the car is destroyed, so are the wheels. This implies life cycle dependencies. So the next one is generalization or specialization. The generalization or specialization represents it is a relationship. For instance, a dog is animal, inheriting its properties but adding unique behaviors. So this relationships helps with code and reuse of hierarchy. So remember, association is like a friendship, composition is like a parent-child, and generalization is like a hierarchy. So this is known as these are the three types of relationship in static models. The next one is examples of static model connections in the software. So here are some example UML class diagrams. Classes are connected through association, inheritance, and aggregations. This shows attributes, methods, and relationships, helping developers understand dependencies. So display classes connected through association, inheritance, hierarchies, and aggregations. They show methods, attributes, and the precious nature of relationship between objects. So the next one is entity relationship diagrams. So entities in a database are linked by relationships that are defined cardinality, one-to-one relationship or one-to-one many relationship or many-to-many relationship, and integrity constraints. The one-to-one and many-to-one or many-to-many, which are depends upon the scenario. Uh, uh, so this is known as entity relationship diagram. The third one is component diagram. Software components are connected to show dependencies and interfaces. So these diagram help break down complex systems into manageable parts. So example analogy. So think of here diagrams as a city map showing streets connecting buildings, UML class diagrams as the floor plan of the building showing rooms and doors, and component diagrams showing how buildings interact with each other in a neighborhood. So this is known as static model connections in a software. The next one is connections in static models, structural perspective. So connections are not only conceptual, they are also exist in a physical engineering analogies. So the first one is pin connections. So which is allow rotation but no movements. Example truss structures. So the next one is roller connections. So which is also allow translation in one direction, useful in bridge supports. So the third one is fixed connections. So the fixed connections also restricts all the movements, providing maximum rigidity. So in software terms, think of this as interface and contrast. Some components are loosely coupled like rollers, while others are tightly coupled like fixed connections. So understanding this helps in both system stability and modularity. So this is known as static model structural perspective. The next one is how connections define system constraints. So connections define constraints and control low elements interact. So they restrict movement, translation, or rotation in structural systems. In software, connections define data flow, control flow, and access paths. So the type of connections determines system behavior under changes or load, ensuring stability to ensuring the stability of the particular behavior. Example, if a database entity is strongly connected to multiple modules, changing it without understanding without understanding its connections can break the entire systems. So proper modeling avoids these kind of issues. So this is known as the system constraints. The next one is practical implications of connection descriptions. So why should we care practically accurate connections modeling brings? So the first one is data integrity, which is the data integrity, which is ensures that interactions are valid and consistent. The next one is clear API contracts. So the clear API contract modules interact predictability of the particular product or particular the requirements gathered from the client or customer. So the third one is modular development. Which is a teamwork and work independently. So the fourth one is automated testing. So the automated testing, which is easier to test components in isolations. So in short, understanding connections improve maintainability, scalability, and reliability of software systems. Ignoring connections is like building a house with no plumbing or wiring layout. So it may look fine, but it will fail under while we use. So the next one is connections are the backbone of the static models. To summarize, these connections reveal the hidden architecture of a system. They make invisible relationship visible and actionable for designers. Um, and also connections types as follows. So the first one is design excellence. Software, the design excellence which will be used in software that it robust, scalable, and maintainable. The better communications. So clear diagram help teams understanding complex systems. The third one is problem prevention. So identifying weak connections before coding saves time and cost. So always remember, in both software and structural design, connections define the strength and behavior of the entire systems. So this is known as backbone of static models. So finally, thank you for watching. This lecture is on connections in static models, keeping practicing creating class diagrams, ER diagrams, and component diagrams to strengthen your understanding. Remember, it's not just about elements themselves, but how they can connect, that they define a system success. Stay curious, keep listening, and keep learning. Thank you so much.